Ever tried following a video tutorial only to feel lost in a maze of confusing steps? You're not alone. Today, we're diving into a groundbreaking dataset that's changing how we understand and summarize instructional videos, especially those for user interfaces. Let's start with the big picture, multi-modal summarization. This is all about distilling long videos into concise, actionable steps by combining text, images, and video. Think of it like turning a 30-minute tutorial into a step-by-step guide with key screenshots. But here's the catch. Most existing tools are designed for general videos like news or movies. They're not built for the unique challenges of UI tutorials, where every click, menu option, and technical detail matters. So what's different about UI instructional videos? Imagine learning to resize a layer in Photoshop. The video isn't just showing you a process, it's teaching you precise actions, like which tool to select or how to adjust parameters. These steps are structured, symbolic, and require a deep link between text instructions and visual elements. Traditional summarization methods. They struggle. They miss the finer details, like the exact menu path or the specific keyboard shortcut. Enter MS4UI, the first dataset specifically designed for this challenge. Created by researchers from Brown University and Adobe, it includes 2,413 UI tutorial videos spanning 167 hours. But this isn't just about volume. The videos are manually annotated with 3 key components. 1. Video segmentation, breaking the video into clear step-by-step chunks. 2. Text summarization, turning each step into concise, executable instructions. 3. Video summarization, selecting key frames that visually highlight each action. Think of it like a recipe. The video shows you how to cook, the text tells you what to do, and the image frames pinpoints the exact moment you need to act. But why does this matter? The researchers tested state-of-the-art AI models on MS4UI and found they faltered. Why? Because these models were trained on generic videos, not the structured, detail-heavy world of UI tutorials. For example, a model might miss the critical step of holding the Shift key while resizing, a detail that's vital for the user. The implications are huge. This dataset isn't just a tool for researchers. It's a roadmap for building better AI assistants, smarter tutorial platforms, and even more intuitive software interfaces. By focusing on the unique needs of UI instruction, MS4UI is pushing the field to think beyond what's shown and toward what's needed. So the next time you're stuck on a tutorial, remember, scientists are working hard to make those steps crystal clear, one precise instruction at a time. Want to explore this dataset or learn more about how AI is reshaping learning? Hit subscribe and let's keep breaking down the science behind the tech. Have you ever watched a long video and wished there was a way to quickly grasp the key moments? That's the challenge of video summarization. And today, we're diving into a study that's testing how well existing AI methods handle this task. The researchers compared different approaches, starting with a classic method called VSUM. It works by analyzing images from a video using a tool called VGG16, which teaches the AI to recognize visual patterns. Then it uses k-means clustering to group similar images and pick the most important ones as key frames. Sounds simple, right? But as we'll see, even this straightforward approach has its limits. To evaluate these methods, the team used a metric called intersection over union, IOU. Think of it like measuring how much 2 shapes overlap, like tracing a circle over a square and seeing how much they share. In video terms, IOU checks how well a model's predicted summary matches the actual key moments in the video. They also used F1 scores, which balance precision and recall, and ROUGE metrics for text summaries, measuring how much the generated text matches human-written references. Looking at the results, the findings were eye-opening. For video segmentation, basically splitting a video into meaningful parts, text-based methods outperformed both vision-only and multimodal approaches. That's surprising because you'd expect visuals to help. But the data showed that existing models struggle to interpret the subtle cues in UI layouts. Meanwhile, multimodal methods, which combine text and visuals, did better at text summarization, suggesting that visuals can help clarify instructions. But here's the kicker, even the best methods fell short. The recall at one metric, how often the model picked the exact right key frame, was especially low. This points to a big challenge, distinguishing similar UI elements or spotting the precise moment a user interacts with a screen. What does this mean? The researchers' new dataset is proving to be a tough test. It highlights that current AI isn't yet equipped to handle the fine details of UI videos. But that's also a chance for innovation, because if we can crack this, we'll unlock smarter, more accurate video summaries for everything from tutorials to software demos. So what's next? The team's work isn't just about beating benchmarks, it's about pushing AI to understand the world the way humans do. And that's a goal worth watching. Thanks for sticking with me. If you're curious about how AI learns to see videos, hit subscribe, and let me know in the comments what kind of AI challenges you'd like to explore next. Until next time. Hey everyone! Ever tried watching a 10-minute tutorial video, only to get lost in the details? What if we could condense that into a 30-second summary that grabs the essence of what's happening? That's the magic of video summarization, and today, we're diving into a groundbreaking dataset that's pushing this tech to the next level. Let's start with the basics. Video summarization isn't just about cutting corners, it's about understanding what's important. Traditional methods like the vision-only approach called VSUM relied purely on visual cues, like spotting key frames or motion patterns. But here's the catch: videos aren't just pictures. They're stories told through text, sound, and visuals, and that's where multimodal models come in. Enter the How2 dataset. This isn't your average collection of videos. It's a treasure trove of real-world tutorials, like cooking shows, tech guides, and art lessons, paired with detailed annotations. Think of it as a roadmap for AI to learn how humans interpret videos. Unlike older datasets like TVSUM, which focused on titles, How2 gives models the tools to grasp context, like recognizing that painting symmetry involves specific steps, not just random brushstrokes. So how does this work? The researchers tested a mix of models. Some, like BERT and T5, are expert at processing text, while others, like PySceneDetect, analyze video structure. But the real star? Multimodal models that juggle both text and visuals. Imagine training an AI to not just see a chef chopping veggies, but also understand the recipe instructions and the timing of each step. Here's where it gets cool. They didn't just compare models, they combined them. For example, BERT to BERT used text summaries to guide video analysis, while models like A2SUM pulled from both audio and visuals. The result? Summaries that aren't just shorter but smarter. And the numbers back this up. When tested on the How2 dataset, these multimodal approaches outperformed older methods by a significant margin. Why? Because they're not guessing, they're learning the language of videos. So what's the takeaway? Video summarization is no longer about cutting content, it's about comprehending it. With datasets like How2 and models that think like humans, we're one step closer to a future where AI doesn't just watch videos, it understands them.